Today's KiCad model is going to be on the basic through-hole resistor. For those of you that are just looking at these videos and you haven't seen any of the others before, what's happening here is this is primarily a Fusion 360 video with a slant, more than a slant, but mashed together with KiCad electrical design automation software. And the reason these two go together suddenly out of nowhere is because in the electronic design application, what you're doing is you're making PCBs and you're making schematics and you turn it into a circuit board. Well, one thing that can happen inside of that is you can view your PCB in 3D so that you could see for fit, make sure nothing's bonking into each other. And if you're going to build a case around it, you can kind of see what the heights are there, right? So it's a pretty good deal. But the problem, I guess, is that the need is that these symbols that we use, like a resistor, like a regulator, like a capacitor, they may or may not have a 3D model for them in the KiCad application. And so we're here to make those. And as far as a fusion exercise, I think it's a really great thing to go after because it does a couple things. I mentioned this in the last video. You can help out the world, right? Because you can make some models for everybody. But also, if you're trying to get good at Fusion 360 and you're looking for something to make, you can start looking around your house and trying to find, shapes and things. And of course, this is great to do. Grab yourself a caliper, start measuring things and going for it. But if you're going to work in a company designing things per somebody else's spec that they've already got laid up, as in a drawing somewhere, it's nice to have a 3D modeled kind of an orthographic drawing or just some kind of a mechanical drawing that you go off of to create this part. And getting used to that is kind of the key. And so the thing that hit me was, hey, I need this, and what a great way to get some practice on here, because all of these data sheets that you look at for all these items, I have one open here somewhere. This is the resistor I was looking at earlier. They'll have some kind of a spec here. And if you watch the other video with the regulator, it's a lot more, drawn out than this, because it's actually a device. So there is tons and tons of these out there that you can get your hands on, these data sheets and parts and things that you need to be making for you to have, lots of things to practice on for a good period of time. So back to this. This is Digikey. This is an online parts supply house where we can get all the different electronic components that we need. And this is their parametric filter. Okay, and going through this, it's not terribly too hard. I think the biggest thing to realize here is don't get too restrictive too quick. For example, up here, if I were to say, I want to find something with, 0.05% tolerance on that, do I really need that? If I really need that, then that might be an okay thing to pick, right? Or do I want metal film? Or do I want, maybe this doesn't matter to me. Maybe what I really want is I just want to buy a basic 1/4 watt resistor that's in something of the realm of like maybe 300 ohms. Nothing terribly too specific about it, nothing too high end, nothing too precision. Well, the first thing I'm probably going to pick, probably just about every time, is I come here and I pick active, because there's a lot of other things going on here. This will reduce it down a touch. In this case, not a heck of a lot. So if you want, you can hit apply filters now. You can stack them all up and hit them at the end if you like. Then I'll hit the more filters, and just to show you, like if you made a couple choices here and you pick this, it kind of remembered. So remember that if you pick something and clicked on a couple things, you see how everything just got super restricted? Make sure you hit the clear button. So hit clear, clear, and now we're back. All right, so then the next thing I think I probably want to pick, I know I'm looking for an axial resistor. That probably seems good. The other thing that kind of looks maybe good is a number of terminations. I'm going to go with the axial one first. I'll hit apply filters. And we probably want a 1/4 watt. That's pretty typical for your small little ones that come in like the resistor kits. So we'll go ahead and hit that one. And then while I'm here, now I'll go for the resistance. Again, I don't care about tolerance or anything like that. I'm not worried about any kind of temperature ratings on these. These are just your basic, simple little resistors. You might not even need to pick the resistance, but you kind of, again, want to get in the ballpark of this, because if you pick one too small or too big, the dimensions might not be the same. At this point, I'm not really sure which one I'm going to need, but I have a suspicion it's going to be around 300 ohms or so, so I could find that one here. And the reason I don't really know, why don't I know? Well, I haven't really made the circuit yet, and I kind of got already an understanding that all these ones around in this area here are probably going to be about the same shape and size. So what will end up happening is this 300 ohm resistor that here, I'll hit apply. Whoa, I got it down to 99. Excellent. These 300 ohm resistors are going to be kind of the model for anything in that range. I'm not going to actually go make a 3D model for the 305 ohm resistor and the 400 ohm resistor, right? And then that brings up these. So then you come over here. If you want, you can go straight for the data sheet. If you want to take another look at it, middle click, by the way, middle click opens up in a new tab. So we'll go ahead and click on this one here, but I wanted to point out that anytime you see one that says series at the end of this, it's not going to be the single data sheet, a data sheet for this single product right here. It's going to sum up a bunch of different ones in their series that they make. Okay, so we'll come back here. We'll want to know this part number in a second. So we'll open up the data sheet, and it's nice. It's got an actual picture of the item, because we want to model to, as close to the real picture as we can. So if you come back here and you look, so you see, this is the artist's rendering of a resistor. And while that's normally fine, we want ours to be a little bit better. So we'll keep this picture in mind. And anybody that's ever done any electronics, you immediately, I bet you can feel this in your hand right now. You know how that feels. And then down here is the mechanical specs. This is just a resistor, so there's not too much more than length and diameter of the thing in the lead, So we look up here. Well, look here at this table, flip back over here, and you can see we've got the CF14. Apparently they don't care about the rest of, or here's the manufacturer part number, CF14 JT300R. Okay, 300 ohm resistor. So you come back over here, we got the CF14, so then we scroll down a little bit, and it looks like the CF14, if you look at the codes right here, this is what we're after. We're going to go work in millimeters here, so we've got 6 millimeters by B, the body diameter right there, 2.7, oops, blurred, 2.3, so 6 by 2.3, and the lead thickness right here of D is 0.55. So that's it for the first part of this. Now we'll go ahead and save this, and we'll jump over to Fusion, design this, then we'll bounce over to KiCad, and we'll make a footprint, and we will bring this in. In the last video, a issue, I guess, it wasn't bad, but a thing that happened was when I created the regulator here, the origin for the regulator didn't match up with the origin of the holes that were created in the KiCad footprint. So I can show you here, and it's not a big deal because I could just nudge it forward in the software and it worked fine. But if I want him to line up this time without having to do that, I'm going to try to think ahead. So here is where origin was in the center-ish of this tab that was there, and in the previous video, it was off centered a little bit, and then you just nudge it and it goes into place. So this time what I'm going to do first is I'm going to make a new component, and I'll just call it PCB. We won't export this out, but I'll go here, and I think I'm doing this okay. So I'll make this much larger than the actual part. Sure, 15 seems okay. Good enough. Then when I extrude this up, I'm not going to extrude it up. I'm going to extrude it down. And if I want, I can make it -2. I don't know what the thickness is in KiCad for I guess we'll figure that out. It's not super relevant right now. That'll be a thing that we'll figure out by the next video. So go like this. I'll pick this here. I'll go into the top, and how about we just do it? We'll draw a line here, and we'll make it a construction element, and we'll stick that on to that point right there. And now this is actually the length of, well, where the holes are going to be, if you didn't figure that out already. So then we'll put another line here. All right, so that's our hole pattern, and then we'll put the circles right here. So these are going to be, remember the pin that we looked at was 0.55 thickness of millimeters. So we'll make this one be, how about 1 millimeter? So then we'll extrude that through. Okay, and then that's kind of our reference. So we'll build the thing to this. So it'll look like it's sitting on the PCB, but we'll make this in its own component. Oops, come on. And then we'll just hide the PCB when we go to export it. Okay, I think I have a plan on this. It'll work out pretty okay. So we'll hit this, and we'll pick this side plane to work off of. So you see here's the top of the PCB right through, and we're working on the plane right through the center. So that should come out okay. This one's not going to be hard at all. With other ones in the future, you might have to plan a little bit more than this. So I'm going to project, sure, why not? I'll project this base as a construction element. And then what I want to do is I want to make a rectangle. Let's make a centered rectangle. Actually, hold up. I've got to draw a line. So if you didn't know this already, when you go over and you hover over something like this and it doesn't snap to it, but if you hover over this and then it does, you see how the little dash line's coming out? If I went ahead and did that, it snaps, but it doesn't stick. So if you want it to stick, draw yourself a line, or, you know, in some fashion or another, get this part done. And I'm going to leave the construction element icon on, and I'll draw, don't put it in the center of that. So I'll draw this. What I'm doing is I'm creating the resistor envelope here that I'm going to go off of. So the diameter of this, bring this over here. So again, our B, the kind of major diameter here, for the 14 was 2.3. Then the length is 6. So that's the size of the package. Then I'll take this and I'll make it so far off the floor. And really this is going to be like something like that, you know? Basically it's touching, but just not quite. And then I'll draw another line, and I'll put it right here, and I'll connect it to the center of this. You'll see why I'm doing that in half a second. Then next, what I'm going to do is continue to draw more construction geometry, which will be the skeleton of the part you're trying to create. And it's a real common thing to do. It's just a lot of people don't do it. So if we're thinking about the shape of the part, you have this kind of dumbbell looking thing about a resistor. We're not just going to make it a square block. We're going to try to make it look like the real deal. So I'm going to come up here and I'm going to go to circle, and this is a good chance to use the two tangent circle. Look at that, right? We could even go with a tritangent. This would be great. Tritangent circle. So I'm going to pick this line right here. I'm going to pick that line right there, and then this one down there, you see? And easy enough to just do it again over here. And there is the two ends of my resistor. Now for the middle, I am going to go back to a centered rectangle here, and I'll bring this out. And you see how I'm snapping to that circle on the right there? I'm going to go ahead and let it do that. And I think I'm okay with it doing that. Did it actually stick to it? Yeah. Be careful moving things around in the auto snaps. You see when I'm moving this right now? Almost always when I go to move something, listen, hold down the control key. If you don't hold down the control key, it's going to auto snap as you move it around. So that'll cause you some grief, especially as you get more and more construction geometry all over the place. Now this, I don't know what the inner, whoa, what just happened there? I don't know what the inner dimension is of this part, but we'll make a guess at it. I think that 1.7 might be okay. We'll let it be like that, but we put a value on it, so it's easy enough for us to change it later if we want. Then the next weird kind of piece of geometry is I'm going to add this out here, and this is representing the lead. So this is 0.55 is what we found out, or what we saw from the data sheet that they are. And then I think maybe lastly for this, I'll draw a construction line. I just stick a big line right out here, take this, and I'll stick it right to center. No, 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 no. There we go. And just because we'll pick the endpoints here. So here is all of, for the most part, the construction geometry. I know it looks kind of crazy, and it might seem, if you don't do this normally, it seems like a lot of overkill. And maybe for you it is, but in a normal professional world, I guess, you know, whatever that word means, this is the way to do this. You spend a lot of time laying out all of your construction geometry, and then we'll use this as a guide for the rest of it. Zoom in here, and we will grab a 3-point arc, and we'll start kind of tracing around this. I'm going to pull this in so it goes tangent over there on the left. Then I'll come up here, and I'll make this and that tangent. So we're done there. This probably should have a dimension on it. 0.3. Let's go with that for now. Right there to somewhere above that area, and then snap up there to the line, to the circle. Then we'll grab another one and go from here to there, tangent to the line. Come back, make this tangent, and you see that's gone awry there. It snaps but doesn't stick, so we'll take that and make them tangent. Okay, everything's sticking where it belongs. Now we can bring this all the way across and do it all again, or we can just grab a line tool right here and go to a halfway point And then we'll mirror everything. There was another feature I needed to create, but we'll go ahead and do this. Okay, so there's the two halves. And then I needed to, could have done this before I mirrored it, but I need to bring this down here. And I need this down here. Get that square. And then one more line to go, oh jeepers. One more line to go all the way across. And that'll close everything in. So now I can look at this and see, you know, does that look like the size that I want it to be? Seems okay now. I think if anything, I'll probably just move this middle section up a little bit. We'll get the whole thing done. We'll look at kind of, you know, eyeball it and see if it looks like the real deal and then modify from there. So then we will exit sketch here, and if you didn't see this coming, we're going to go to a revolve. So you see how revolve works right there? It's also up here. Hit that, pick this, and then for the axes, this is why we added that line through the middle there, so we can spin it around it, you see? Now, this accommodates the size. The box here was the total size of what the supplier says that it is, but this little extra here is what I've seen in real life, you know, just to be that extra little bit of fillet that's created from the dipping it into the coating, you see? And so that just makes it look a little bit more realistic. And of course, it's the same size as what will be the lead coming out of it. So when we go to make the leads, they'll be in here and just come out right through. So, done. And then if this is flat, make sure you're looking at flat, that should be just our, you know, 1/10 of a millimeter sticking off of the PCB. So far, so good. For the leads, we're going to do this the same way we did in the last video, which is probably going to be extraordinarily common for all these electronic components. We are going to create a sweep. So we'll need a profile, which will probably be just this circle at the end here, and then a shape to follow, a path to follow, which will just be a curve going down here. Now, rather than just go ahead and start from where we are now, we're going to make this, we're going to make the leads be a separate component. And that's really just for the ease of creating different appearances. It really doesn't matter. You can make them different bodies. Yeah, what the hell, let's do it that way just to show, right? Instead of making a separate component called leads, think about the appearance thing right here. You can pick bodies or components or faces, okay? So if this whole thing with the leads is one body, when you go to pick something, it's going to be all the same color unless you want to go with faces. Then when you pick faces, if there's multi-facets through here, then you might have to end up picking a whole lot of crap to get it to be the color you want. So this is what's determining my decision right now. So we'll try this. We'll go here, and I'm going to pick this plane right like so, and I will project this forward right there, because what I want is, I want, make it a construction element, I want a halfway point. So I'll grab a line tool here, and I'll snap right to the center. Then I'm going to bring this out. See, here's the hole where we're headed. Matter of fact, let's project that also. Let's tilt this a little bit. Pick that, project, turn this on. There we go. Now we have a start and a stop point, sort of, over here. But what we want to also do is draw a line that goes from here all the way down through. And yeah, here's what we'll do. We'll go like this, and we'll say that this thing is so far away from there. So we'll say that it is 1.5. Yeah, maybe 1.5 millimeters away from the bottom. Then that way, if when later I find out that the KiCad PCB thickness is a little bit different, I can change the thickness of ours right here, and this will still stick out the right amount, I guess. Then we can now turn this off. We can go pick our line tool again, snap right to center there. Now when you bring this out, bring it out. We did this in the last video too, right? Bring it out and then hold it down. If you hold it down, it'll just switch right over to a curve. Then you could bring it out to where you believe, it probably should have came out a little bit further, but you bring it down here and then you can bring it down like this. And so I'm going to bring it right down to the end there. Then I'll take this and that and make them collinear. Then this line right here and right here will make those tangent. Put a radius on that. 1 millimeter. Then everything seems to look okay. So this will be the path for our profile that we're about to do to follow. To create a sweep, you go up here. In CATIA they call it a rib, right? But it's a sweep here. So to create a sweep, we need the profile and the path. And if you wanted to, you could just click it right now and you could say the profile is the shape at the end here, and then the path to follow is that. So you see, we could do that, but I prefer to make a separate sketch, and it basically has to do with the timeline. So down here in the timeline, if I want to edit something, I see that there was a sketch made, and I'll see a sketch, and then the sweep feature. So I know that one of the sketches was the profile, one was the path to follow, and then the sweep feature that made it. You do what you like though. So I hit this and I'll click there, and I'm going to project that without being a construction element. Exit sketch. Then go to your sweep function. Pick that sketch. Make sure you're actually getting the sketch, by the way. If you're ever uncertain, you can hide the body. You see? Just to make sure you're linking properly. And then the path is going to be over here. And now this last part, this is important. We want to make sure that this is a new body. Okay? If I wouldn't have, I think it happened because I unhit it, but it automatically changed here. But normally you have join, cut, and all that. Make sure that you've got new body. If you wanted to, you could straight make a new component with it right there as well. But we'll do this. Hit OK. Makes the body over there. I can unhide the other one. And as far as, you know, things are concerned here, that it looks like it's one component. But when it comes to coloring the thing, adding appearance to it, it'll be easier for us to say that this is, you know, tin colored or something, rather, you know, as a body, rather than this feature, this feature, this feature, etc. Then the last thing, I'm going to go ahead and hide that one again there, is to create a mirror. The object is going to be this. Now, do you want faces or features or bodies? So we're going to say bodies. I want that. And the mirroring plane is going to be right there. So that's a piece of cake. That's done. Two separate bodies, by the way. And now the two come together. You see? All right. Well, I think it looks pretty good, but I'm going to go back and let's see. Edit this one right here. This thickness right here. I'm going to bring that up a little bit more. Yeah, that looks better. All right, let's add some color to this thing, and I think call it good. Probably plastic. Let's go with some glossy. Well, you know, it kind of doesn't matter which one you pick. We'll go with blue, and you see how I've got it selected up on top on bodies? So that will be that one there. Then I can come back and I can edit this and make it, I like those little light blue teal ones. How about that? That looks nice. Maybe a little bit bluer. Nah, we'll go with that. So there's that. And then for the leads, we'll go with metal, and we could go with lead, I guess. Satin lead. Stick them on the legs here. What do we think about that? Yeah, that seems fine. Hey, that's our resistor. Close. I imagine that you could probably stop at this point and it would be fine. But as usual, I'm going to go a bit further with this. So let me just keep working away here, and I'll be right back. I think that looks pretty good, and so as you can see, I added another band to it. If you look at it like this, without all the lines on it, pretty nice. I'm going to add one more feature, just because. To save you a little bit of pain, I flipped over to KiCad. I realized that I guessed in a couple of really bad ways. So to be a little bit more to spec, this right here was a 0.55 lead. So according to IPC, the hole for that should probably be about 0.25 millimeters larger in diameter than the lead diameter is what you're supposed to go with. So I went ahead and changed that over on the PCB, which doesn't make really any big damn deal to this now. But then also the annular ring, the pad here, just thinking off the top of my head, I was thinking 3 might be an okay size diameter to go with. Well, it's really extra large. So if your hole, okay, this is not IPC, but just as a rule of thumb that I've seen with all the other footprints that are made, if at this size scale, I want to say, because I think this is probably going to change as you get bigger, larger, smaller, whatever, but around this size scale, if the hole is, say, 0.8, double it, make it 0.16. So that's what I did there, right? If the hole is 1.2 millimeters, make it 2.4, okay? Now, I'm not sure what KiCad uses for its board thicknesses, but it was a little bit, this was sticking out a little bit more. And so the standard from the board house is usually about 1.6 millimeters for a typical 2-layer board. So I went ahead and went with that. I think my little stumpies here, my little solder joints probably are a little bit on the silly side, because if your board does change thicknesses, then this is not going to work so good. But whatever. Moving on.